Good day, everyone. For Mathematics Reinforcement, Week 1, Day 1, we have the topics about, the subtopics on angles. Angle is under trigonometry, and trigonometry is from two Greek words, trigonon, which means triangle, and metri it is from the Greek word metron, which means measure. So for us to describe what trigonometry is, it is about the measurement of triangle or triangle measurement. For the description of angle, you already know this, that the angle is the union of two rays meeting at a common point. So just like what you can see on the illustration here, so this is how an angle looks like. And the angle has parts. The first part is the initial side. We have the red dot, which is the common endpoint. It is called the vertex. And then the terminal side. If you are going to compare the terminal, the initial side is actually the ray or side of the angle that is stationary. While the terminal side, it is the side of the angle that moves. It is the one that rotates, either clockwise or counterclockwise. We also have the symbol for the measurement of the angle. We do have theta. There are also instances that instead of theta, you can use the Greek letter alpha. You can also use beta. Another one that you can use is the gamma. Okay? You can see in some references, whether on books or online, that angles, the name for the angles, well, we can also use letters. So naming it as angle A, angle B, angle C, so on and so forth, or any letters from the English alphabet. Also, we have the quadrants. So this is also a review for you. So we have four quadrants. On the upper right, we have quadrant 1, in which the measurement of the angle is in between 0 degree and 90 degrees. On the upper left, we have an angle whose, in which the measurement is in between 90 degrees and 180 degrees. On the lower left, we do have here quadrant 3. The angle measures between 180 degrees and 270 degrees. And in quadrant 4, which is on the lower right, the angle measures in between 270 degrees and 360 degrees. So if you will be asked, for example, um, in which quadrant can you find 100 degrees? Okay. So of course, since 100 is between 90 and 180 degrees, your answer would be what? Quadrant 2. If you have, say, for example, 355. So 355 degrees is in quadrant 4. Please take note that even if the angle would become negative, the quadrants will be the same. Okay, what do I mean by this? So remember that if we have this illustration of the quadrants, you would notice that all angles here are positive. Since if you can remember that if the rotation, the rotation, or say the direction, okay, the direction of rotation of the terminal side is counter. So if it is counterclockwise, it means that we do have a positive angle. So just like this one, we have here 0, this portion. So it means that we have the initial side here. And on the initial side, it is from where the rotation will begin or will start. The side that rotates is the terminal side. So if the terminal side will rotate counterclockwise, so this is 0, okay, rotating counterclockwise, we do have here 90 at this portion. Continuing, we have here 180 degrees. Continuing, we have 270 degrees. Continuing, we do have 360 degrees, so on and so forth. Okay, that is counterclockwise. We also have another direction, which is clockwise. If the rotation of the terminal side is clockwise, so it means that we do have a negative angle. For the negative angle, so the same, we do have the initial side in this portion. So the beginning or the starting point would be here. And then with the terminal side rotating clockwise. So like this one, so it rotates clockwise. So this now will be a negative angle, which is negative 90 degrees. Continuing clockwise, at this portion, we do have here negative 180 degrees. I hope that you can remember your angle. Next, continuing clockwise, so this will become negative now, negative 270 degrees. And then continuing again, so we have here negative 360 degrees. Okay. So as what I've said a while ago, even if the angle is negative, the quadrant will still be the same. So example, if you will be asked, okay, quadrant of, well, in which quadrant can you find, say, negative um 285 degrees. Okay? So negative 285 degrees, it is actually in the first quadrant. Okay? So it is in quadrant 1. Why? Because negative 285 degrees is between negative 270 and negative 360 degrees. Okay? If you will be asked, in which quadrant can you find negative 200? So negative 200 is in quadrant 2 because negative 200 is between negative 180 degrees and negative 270 degrees. Next. Let us now have the kinds of angles. For the kinds of angles, so I will be presenting to you the 6 kinds of angles. This is also a review. So the first one is the acute angle. Remember that the acute angle, it is less than 90 degrees. The right angle, so it measures exactly 90 degrees. And the obtuse angle, that is between 90 degrees and 180 degrees. So these are the first 3 kinds of angles. We also have another 3 on the next slide. So we have here the straight angle. So it measures exactly 180 degrees. The reflex angle, and then the last one, the full angle or a complete revolution of 360 degrees. So those are the kinds of angles. We do have 6. Next, a review of the complementary and supplementary angles. You can still remember. So for complementary and supplementary angles, we always consider two angles. In the illustration here on the left, this is actually an example for complementary angles. And if you try um, to notice that the two angles here are alpha and beta. So the complementary, okay, for the complementary, remember that when we add angle alpha and angle beta, the sum is 90 degrees. That is for complementary. So example, you will be asked to, okay, let us have an example here. So you will be asked to say, find the complement. Okay, find the complement, or what is the complementary angle of alpha that measures 70 degrees. Okay, so the complement of this, or the complementary angle is of course beta equals to 20 degrees. Because 70 degrees and 20 degrees, when you add it, the sum is 90 degrees. Okay. Another. What if you will be asked of the complement of, say, 84 degrees. Okay? So the complement of this is 6 degrees. So 84 degrees plus 6 degrees equals to 90 degrees. Class, just remember, for complementary, we do have here, well, we do have here a description for this, for the complementary. Always remember that both should be positive. Both should be positive angles. What do we mean by it? It means that if one angle is negative, therefore it won't have a complement. Therefore, you're gonna answer none. So example, um, if you are given alpha, which measures negative 10 degrees, so what would be its complement? Of course, its complement would be none. Because the condition for complementary angles, both should be positive. If one is negative, therefore you do not have a complement. Also, another thing, since the sum should be 90 degrees, if one of the angles is greater than 90, for example, beta is 115 degrees. Therefore, it won't have a complement. So the answer is also none. So this also applies to supplementary angles. I'll erase the writings on the right side so that we can see the supplementary. So the supplementary angles, this is also somehow the same with the complement. The only difference is that the sum should be 90. Rather, the sum should be 180. Okay, so if we have two angles, so alpha plus beta equals, so sum is 180 degrees. You also have to take note that both should be positive. So if one is negative, again, your answer would be none for the supplement. Okay, just remember that. So let us have an example here. So say that beta is, say it is 100 degrees. So its supplement is alpha, which is 80 degrees. That's it. If ever that you have negative 100 degrees, because it is negative, therefore, your the supplement would be none. Okay. Next. So this is to show you on the next slide the special angles. For the special angles, we have 30 degrees, 45 degrees, 60 degrees, 90 degrees, and their respective multiples. When we say respective multiples, for example, since 30 degrees is considered to be a special angle, so its multiples are, we have 60, 90 degrees, 120 degrees, 150 degrees, 180 degrees, so on and so forth. The same also applies for 45, 60, 90 degrees. These are special angles. Next. Um, for the direction of the angle, I already explained this a while ago when we discussed about the quadrants. So just to show you direction of the angle in standard position. So for the counterclockwise, so if you can remember when we say counterclockwise, we have an angle that is positive. So we have a positive angle. And here in our illustration, this is actually an illustration of an angle in standard position. When can we say that the angle is in standard position? So number one, okay, the first thing that you need to remember, it should be in the Cartesian plane. The angle should be drawn in the Cartesian plane. Next, the vertex of the angle should be at the origin. So as what you can see, this angle is in the Cartesian plane. So this is the x-axis, the y-axis, with the vertex at the origin. Another, the initial side should coincide, or it should be along the positive x-axis. So with this angle, if you can remember the Cartesian plane, we have, if this is the x-axis, and then this is the origin, on the right side, we have positive x. On the left side, we have negative x. On the upper portion, so since this is y-axis, so this is positive y. And below, we have negative y. So with the initial side at positive x-axis, it is, it is very clear in our illustration that the initial side of the angle is along the positive x-axis. When it comes to the terminal side, remember, the terminal side moves. So it can be anywhere. It can be in any quadrants, or possible on the y-axis, positive y-axis, negative y-axis, or negative x-axis. Okay? Possible also that it can be in the positive x-axis because it can move anywhere. So with the counterclockwise, I already explained this a while ago. So if you have, if the terminal side rotates in a counterclockwise direction, the angle is positive. Also, when the terminal side rotates in a clockwise direction, so the angle is negative. So we have here a negative angle. And if you try to check, so The angle is in the Cartesian plane. So we have here the x-axis, the y-axis, and then the initial side is along the positive x-axis with the vertex at the origin. Okay, so that ends our discussion for week 1, day 1.